The seasonal formation of superglacial lakes on the Greenland ice sheet and the subsequent drainage of these bodies of water have a substantial and important effect on ice dynamics in the region. The importance of studying this phenomenon and the resultant increase in studies conducted in recent years has shown that there is a potentially fundamental link between the proliferation of these lakes, the resultant drainage of the meltwater, and the increase in ice sheet movement in Greenland. It has been suggested that the projections for future sea level rise may be considerably underestimated by the IPCC. Therefore, understanding the dynamics of this movement and the processes that govern it are integral to understanding the implications of increased ice sheet movement and what the potential effects of future global warming might have. The formation of these lakes themselves may be an important indication of climate change, and could allow important insight into the changing mass balance of the Greenland ice sheet. As well as having implications on future modelling scenarios, this data can be used to get better understanding of how climate is changing across the Greenland ice sheet. In recent years, the utilisation of aerial photography and remote sensing techniques have been used to measure and map the extent of superglacial ice lake formation in attempts to better understand how the drainage of these lakes affects the glacial hydrology of the ice sheet. Superglacial lakes begin to form as the surface meltwater initially flows and begins to pond in surface depressions and crevasses on the ice sheet. The topography and presence of surface features such as crevasses is noted to exert a first-order control on the location of these lakes. Importantly, although lakes vary in size, the larger of them can be in the magnitude of several kilometres in diameter, while being several metres deep at its centre, therefore constituting a substantially large volume of meltwater, especially when we consider that thousands of these lakes can form during a single melt season. The significance of this large volume of pooled water is its ability to potentially reach the ice bed interface due to the propagation of crevasses and surface fractures through the processes of hydrofracture and the production of moulins within the ice lake basin. It has been recorded that some lakes can drain within a single day, with the flow power equivalent to the Niagara Falls. This meltwater then has the ability to lubricate the interface, potentially increasing the basal pressure and aiding the presence of basal sliding. This has the result of accelerating the ice sheet, sometimes up to 100 to 200% increases in speeds seasonally. Therefore, understanding the effects of superglacial ice lake drainage is integral to improving future modelling and understanding of Greenland's ice sheet mass balance. MODIS, or Moderate Resolution Imaging Spectroradiometer, is a key instrument aboard the Terra and Aqua satellites flown and controlled by NASA. Terra's orbit around the Earth is timed so that it passes from north to south across the equator in the morning, while Aqua passes south to north over the equator in the afternoon. Quoting NASA, they state that MODIS is playing a vital role in the development of validated global interactive Earth system models able to predict global change accurately enough to assist policymakers in making sound decisions concerning the protection of our environment. To do this, the MODIS instrument provides high radiometric sensitivity, 12-bit and 36 spectral bands ranging in wavelength from 0.4 micrometers to 14.4. The responses can then be tailored to the specific needs of the community using the data and provide exceptionally low out-of-band response. 2 bands are imaged at a nominal resolution of 250 meters at nada, while 5 bands at 500 meter and the remaining 29 bands at 1 kilometer. A plus to negative 55-degree scanning pattern at the Earth Observing System orbit of 705 kilometers achieves a 2,330 kilometer swath and provides global coverage every 1 to 2 days. A recent example of the MODIS satellite being used to monitor the Greenland ice sheet can be seen. The Penman Glacier is an outlet glacier flowing towards the sea along the northwestern coast of Greenland. It terminates in a giant floating ice tongue. In mid-July 2012, a large ice island broke free, and Modis' twin Aqua and Terra satellites were able to capture the event. By mid-August, the ice sheet had floated into the Nares Strait, heading towards the North Atlantic. The piece of ice was equivalent to roughly 46 square miles. It is commonly believed that enhanced global warming is to blame for the event. Greenland, which is covered 4/5, that's roughly 80%, by glaciers, is warming at an unprecedented rate, with its northern region increasing by 4 degrees in the last 30 years. Scientists say if more pieces of the Penman Glacier break off, sea level could rise even further. MODIS daily land surface temperature and a special diurnal melt product derived from QuickSat scatterometer data measure the evolution of melt on the ice sheet. Although these daily products are sensitive to different geophysical features, they show excellent correspondence when surface melt is present. The 2000 melt season is shown 2 times. The first time, MODIS surface temperature is shown compared with several categories of QuickSat melt. Initial melt detected by QuickSat is shown in light blue melt. Melt detected under a refrozen surface is shown in medium blue, and completed melt is shown in dark blue. For the MODIS temperature data, regions with a surface temperature greater than -0 or 1 degrees Celsius are classified as melt and are shown in red. The second time through the melt season, only melt regions of the MODIS and QuickSat are shown. During this comparison, MODIS temperatures greater than or equal to 0.15 degrees Celsius are considered melt and are shown in red. These regions are compared to the QuickSat, where all melt categories are shown in dark blue. As you can see, there is excellent correspondence. To conclude, the changes that are occurring on the Greenland ice sheet are very dynamic and are occurring over large spatial scales, over low temporal scales, making them very difficult to monitor and measure effectively. Instruments like MODIS offer us a solution to this problem, and further use will give us a better insight into the changing environment.